Hi everyone, welcome to another video of 8kpc HyperConverged Appliance Deep Dive series. Today we have Ravi with us, and Ravi is going to walk us through the 8kpc orchestration. Over to you, Ravi.
Thank you, Anand. So welcome again. Today we're going to look at orchestrating and setting up an 8kpc appliance at your data center. So the 8kpc appliance comes in one new single node, and you always set up 8kpc appliances in pairs. As you can see on your screen, each 8kpc appliance here is represented as a mirrored pair of two nodes to provide complete redundancy for hardware and software failures. Okay, so now we're going to take a look at the 8kpc appliance hardware configuration first. Each appliance has a dual CPU from Intel Xenon 2600 series, and it has memory configurations starting from 128 GB all the way to 512 GB per node. Each appliance also has multiple flash drives and hard disk drives, creating a layered storage architecture which is embedded in each node. Each node has dual network ports in it. There are two 10 gigabit Ethernet ports, and there are two 1 gigabit Ethernet ports, providing full redundancy for network connections into 8kpc cluster. The 8kpc storage is configured in flash primary, which uses the inbuilt SSD drives, and bulk primary that uses the HDD drives. You can configure secondary storage also for backup purposes using the inbuilt hard disk drives which are available in each 8kpc node. Now let's take a look at the 8kpc software architecture. The 8kpc hyperconverged software creates an abstraction layer of the underlying hardware and provide complete redundancy and always on cluster. It creates a scalable software defined storage that spans across all the nodes of the cluster. This architecture ensures no data loss by creating multiple copies, along with ensuring no performance penalties with near zero latency as the cluster scales from 2 nodes all the way up to 64 nodes. The 8kpc software, along with Citrix Zen Server hypervisor, creates a single stack of high performing appliance to run workloads with extreme ease and simplicity. We will discuss the 8kpc architecture in greater detail in our future videos. Now let's take a look at 8kpc in action. Anand, could you walk us through the 8kpc orchestration demonstration, please?
Sure. In this demo, we will orchestrate the 8kpc appliance. As part of the demo, we would first go through the add node process and create a new 8kpc cluster, then add virtual store followed by storage resource. The version of 8kpc HCA software and 8kpc scalable SDS used in this demo is R2.2. Orchestration is a simple single-click process that completely automates all the steps of setting up storage, Citrix Zen Server, network, etc. All that would have taken a week to configure and orchestrate gets done in a matter of few minutes. The 8kpc add node is a mandatory step for every appliance added to the 8kpc 10G private cluster network. 8kpc appliance is configured with an IPv6 address for first-time access. Access the appliance over this 10G network using Chrome browser version 55.x or later. Ensure that Chrome has IPv6 enabled and point Chrome to IPv6 address provided by 8kpc in square brackets to access the 8kpc UI. This launches the 8kpc Management Console UI. Let's go ahead and provide the credentials and login. Now that we have logged in, let's go ahead and click Add Node from the drop-down menu. This will open the window to add the license file. The license file is sent as an email attachment to you by 8kPC. Choose the license file and click Upload. Once the license file is accepted and validated, the Add Node UI comes up, which we will now use to configure the settings. Since this is the first appliance pair, we need to create a new cluster. Providing the cluster name followed by IPv4 address for 8kPC 10G fabric connectivity. This will configure the fabric subnet. The subnet will be used for 8kPC 10G fabric internal communication. The local host IP address provides the 1G IP address to the Citrix Zen server. Note that the IP address is entered with CIDR notation. Next, we configure the fabric network such as DNS and gateway. These are optional settings and are needed if the 10G fabric is shared with other clusters. Configure the host name for each of the two nodes. We are calling these here as 8kPC01 and 02 respectively. Let's keep the management network on 1G. This is the network we will use to access the 8kPC management UI. If you plan to access the UI over 10G network, then choose 10G. For this demo, let us use physical disks. Next, let's assign password to the Zen server, confirm the password. We will now configure the Storage Manager or SM. The Storage Manager is an 8kPC controller VM. It orchestrates, manages, and monitors the 8kPC cluster. The 8kPC management UI is also hosted in the Storage Manager. The Storage Manager runs as a paired VM in the first appliance pair to provide high availability. The Storage Manager needs 3 static IPs in the same subnet on the 1G network to configure automatic checks for upgrades from 8kPC, enable internet access to this 1G network. The primary SM access IP and the secondary SM access IP are 2 internal IP used by both Storage Manager VMs. These IP addresses should be entered with CIDR notation. SM virtual IP is used by SM user interface to provide access to administrator. Set up the DNS and gateway IP address on the 1G network. The 8kPC management UI can be authenticated either as a local user with management done by 8kPC locally or using the Active Directory services. By default, the 8kPC Storage Manager comes up with a default super user admin. For more details on user management and users, refer to admin guide. To configure the Active Directory, select the Active Directory field and provide the necessary inputs. Configure the NTP server setting with an external NTP server to keep 8kPC and Citrix Zen server cluster servers in time sync with each other. It can be left blank if the 8kPC appliance is set up on a network with no access to NTP server but needs to be configured later in the settings. Then click Add Node button. Once the Add Node process is initiated, the 8kPC Add Node workflow performs multiple steps in the background. It initiates by starting the Storage Manager VMs, configures the 10G and 1G network, then configures the high availability between the paired storage managers, sets up the security for Web Console including the SSL certificate. It then enables the virtual IP of the storage manager, creates the Citrix Zen server pool, adds the nodes to the Zen server pool, brings up the system successfully, and displays the 8kPC management UI. As a best practice, it's best to log off now from the 10G network and connect back to 8kPC management using the IPv4 SM virtual IP. In the meantime, as the Add Node process completes the configuration, let's look at some of the aspects of 8kPC management UI that are used to orchestrate, manage, and monitor the 8kPC cluster. This is the dashboard view. It provides an overview of the cluster. Here it shows the consumed versus total capacity status of the flash primary, bulk primary, and the secondary store. The performance of various system resources such as CPU, memory, and storage IOPS are displayed here. And finally, on the left side, you see details such as number of nodes, number of VMs, virtual stores, and storage resources or data store. The system view provides a more detailed view. It provides information at individual node level. It also has the provision to create virtual store and add storage resources that we will see later in the demo. It also provides an option to recycle, start, and stop the node. The system events are displayed in both the views, categorized as critical and information alerts. And finally, the Zen Center view, apart from providing all the vital information of Zen server and VMs, shows that the 8 kPC storage resources and the virtual store are successfully connected and available to administrators to deploy virtual workloads. Once the add node process is over, the node level information is available in the system view. The intuitive 8 kPC UI guides through the next steps of creating virtual store by making the create virtual store option visible and adding the storage type needed for the particular workload. Let's go ahead and create the virtual store. Provide a name to the virtual store that denotes its characteristics such as VDI high IOPS. The virtual store is a logical abstraction of the 8 kPC HyperConverged Appliance, creating a virtual appliance. The virtual appliances across the nodes jointly form the 8 kPC HCA cluster. During the virtual store creation, the network for storage gets configured to enable high availability, and the 8 kPC storage services get enabled and started to create the 8 kPC scalable software-defined storage. The next step is to add storage resources. At this step, you can create the storage type needed in terms of throughput, tiering, etc. There are 3 types of storage options available: only flash, SSD based, only hard drive, or hybrid. You can also choose to configure the storage for hosting VDI VMs or user data. The option to flush data across layers periodically can be enabled from the flush option. This creates a copy of data in the secondary store and helps recover in case of data corruption. If not configured, 8 kPC has defaults based on storage usage to flush the data across layers. During this add storage process, volumes or data stores are created and provisioned to the 8 kPC SSDs. These are then mounted as Zen Server storage repository. The virtual store and the storage resources are now visible in 8 kPC Management UI as well as Zen Center UI. This concludes the 8 kPC orchestration and the demo.
Thank you, Anand. I hope this video was informative. In the next set of videos, we will discuss about 8 kPC architecture in detail and cover more of the features of the 8 kPC HyperConverged Appliance. Hope to see you soon. Thank you.
Thanks, Ravi.